Hello guys, this is Prof and welcome to another episode of our Programming with Modern C++ video tutorials. I trust you guys are doing great and taking precautions in this COVID season. Now, once again, I am very excited to share with you. So fasten your seatbelt and let us take a ride together. In this video, I'm going to talk about the fundamental data types in C++. Now, every program that we will write in C++ will need this. The fundamental data types serve as the foundation upon which object-oriented capabilities are founded. Now, they are called fundamental because they serve as the building blocks upon which all other data types that we will be using or creating are founded. Okay. Now, this video builds up from the previous video, so please, if you haven't watched the previous episode, I will urge you to go and do that, okay? Else there are certain things that you might not understand. This is the outline for this tutorial. The main topic is on data types, variables, and data. And in this, I'm going to focus on integer variables and integer literals. So let's look at data types and variables. When we talk of a variable in programming, it is an allocated or a named piece of memory. So every variable that you create in C++ must specify the type of data it can store. The fundamental data types are identified by unique type name, and that may consist of one or more keywords. In my previous video, I talked about keywords as names that are exclusive to C++. Now, this means that they are reserved words that have meanings in C++, hence they cannot be used in a program by any programmer. So we can't use them in our code to name anything because C++ has a meaning for them. Now, the compiler during compilation checks to ensure that you have used the right data type in any given context. Another thing that the compiler does is to check for compatibility when you perform operations involving different types. The compiler will always make sure that at least when different types are used, one type can be converted to another, else it will throw an error if the data types are incompatible. Now, data types serve two main purposes. The first is that they specify the kind of operation that can be performed on the stored value, and also the size of memory space in bytes that should be allocated for the data. All numerical values in C++ can be grouped into two main categories. We have the integer data type and the floating point data types. Now, the integer data types are used to store negative and positive whole numbers, and by whole numbers we mean numbers that do not have decimal points in them. Floating points, on the other hand, as we discussed in a previous video, are used to store numerical values with the decimal points in them, such as the value of pi. These two categories have fundamental types, each of which can store a specific range of values. The fundamental types under each category differ by size. For the floating point types, the fundamental types do not just differ by size but also by the level of precision that they can offer. Now, let us look at how we can define integer variables in our C++ programs. Defining an integer variable is done using the following syntax. You specify what we call the data type, then you give a name to that variable. So here we call it an identifier. Is that okay? This defines a variable of type int with the name age. The name we assign to the variable is a convenient way of referencing the value we have stored in the memory. The computer uses addresses to reference its memory, so it will be inconvenient to store these memory addresses in our head while programming. Okay, let me use this analogy. The best way to universally locate any place on earth is by using the GPS coordinate, for instance. Now, unfortunately, GPS coordinates will be difficult to remember offhand. Now, imagine someone or a friend sitting in a car calls you and asks, "Hey bro, where can I find you?" And at that instance, you have to call out the GPS location of your house. That would be so unfortunate. Now, to remedy this problem, we humans assign very comfortable names, okay, to places without worrying about remembering their GPS coordinates. So we have names like Ghana, Africa, Nigeria, Nima, Choco, California, and Nebula, etc. Now, similarly, whenever we are programming, we assign names to the memory locations the computer assigns to us, so that it will be easy to remember and use them. Now, one thing I want you to note is that your program does not take the needed memory by itself. What happens is it sends information to the underlying operating system, which is in charge of managing the resources of the computer. Then the operating system assigns an available memory to your program for use. Now, the memory space the operating system may assign to your program may have been used by a previous program, hence there may be some arbitrary values in them. Is that okay? So it is a good programming practice, or it's a good habit to always clean the memory before use. The cleaning is done by setting a specific value as an initial value when you define the variable. Okay, this is called variable initialization. The syntax for initializing a variable is very simple. You just start by saying data type, then you specify the name, okay, then you put the value in between these two curly braces. So for instance, in our previous example, to create a variable to store the age of a student, we can do something like int age. Then if the student is 19 years, that we will replace the value here with the number 19. The initial value appears between the curly braces. Now, the braces enclosing the initial values are called brace initializer. Brace initializer. This method of initializing variables was introduced in modern C++, so it is not available for those of you who are using the old compilers. It is called brace initializer notation, or the uniform initialization. Let us use sample code to demonstrate this. Okay, so in this code, in this program, all I have done is create 4 variables, okay, of different types. So starting from line 9, I have int representing the data type and my age representing the name or the identifier. Then we have a character variable here, so we are using the data type char. Then we have a floating point variable with the name account val, and we have a boolean. Booleans represent true or false values, okay, so we have a boolean, and the identifier is leap year. So this is how you create variables in C++. Using the brace initializer does not only assign an initial value, they also make sure that the data type of the initial value is the same as the specified data type of the variable. If that is not the case, then it will try to convert the data type of the initial value to that of the variable. If the compiler detects a potential loss of information, the compiler will raise an error. So for instance, assuming I want to store the number 3.142 to an integer variable, you see, integers do not accept decimal points. So to store a decimal number as the initial value will mean that the decimal side will have to be truncated. Is that okay? And this is what we mean by loss of information. And such situations, your compiler is going to raise an error or at least a warning. A conversion to a type with more limited range is what we call narrowing conversion. So you have something like a floating point number, and you are converting it to something like an integer. You are definitely going to lose the floating point, the floating part of that number. So this is called narrowing conversion. Anytime a bigger data type has to be converted to a smaller one, we call it narrowing conversion. Using the brace initializers in modern C++ safeguards your code against such cases. There are other ways of initializing variables. We have the functional notation and the assignment notation. We shall look at an example very soon in code. Okay, so the functional notation and assignment notation are both valid ways of initializing variables in C++. Okay, and they are mostly equivalent to the braced initializing method. Now the question is, what makes the difference? Okay, what makes the difference? Using the braced initializer provides narrowing conversion checking, and that makes it preferred. So in this tutorial, I'll be using the braced initialization method extensively. Another advantage of using the braced initialization is that it enables you to initialize just about everything in the same way. Okay, if you look at C++, arrays are initialized using the braces, classes using the braces, and structures using the braces. So this is why we call the braced initialization notation a uniform notation, or a uniform initialization, because once you get used to it, that will be the way you do almost all your initializations in your code. Let's look at a sample program to demonstrate this. Okay, so in this code I have defined I have demonstrated the various ways. So over here we have a sample code showing the braced initialization or the uniform initialization method. Then we have sample code showing the functional notation method. Then we have the assignment notation. Now please don't try to run this program. You can see that I'm using the same variable names throughout. Okay, in C++ program you can't define two variables with the same name. Now I'm doing this just for the purpose of demonstration. Is that okay? So please don't try to run this particular code. It will not work. It will give you errors. All right, now so in here I have defined an integer variable, and I have given it an initial value. Okay, remember we said initialization, so we are trying to set a value to it. So I've set an initial value of 20. I have a character data. I've set character M to specify gender, floating point 28.0, it's a leap year, true. Now look at year of birth, very fantastic one. You can see that here I'm performing an expression, and the expression is being evaluated before the value is assigned. Okay, and this is totally acceptable in C++. You can put any expression here so far as that expression will evaluate to the data type that you specified here. C++ will go ahead to evaluate the expression for you before it assigns the value to the variable. Now the difference is that in the brace initialization we use the braces. In the function initialization we use the parentheses. Okay, but if you look at it, you can see that that's the only thing that is different here. Okay, the assignment operation is what most of you are used to in the old C++ standard. Okay, so we have a variable and we call the assignment operator and assign it a value to the right. Okay, so here we are assigning capital M to gender, we are assigning true to a leap year, and we can also evaluate this expression and assign it to the year of birth. So any of this, please take note, any of this way of or method of initializing variables is accepted, and it is a legal C++ code. Okay, now the reason I am going for the braced initialization is because of the fact that it performs narrowing conversion checks. Okay, and the other cool stuff. Now about the narrowing conversion check, let's look at this. So in here I've created three different variables. Okay, not three different variables, actually same variable, same name, but I'm using the three different notations. Is that okay? And again, I can't run this code with the three variables of the same name. Now what I'm going to do is, look at this. As of now, all of them are of type int, and the values I've set to them are all type int. So let me comment out line 17 and line 20 so that I am left with only line 14. Okay, you can see that it compiles. There are no errors, so we have error 0, warning 0. Okay, now let me comment this out and uncomment this and then compile the code. Again, it compiles successfully, no errors, no warnings. Then now the assignment notation, Let us compile it. And again, no errors, no warning. So you see, all these three methods are perfectly legal ways of initializing variables. Now, the difference now is, let me comment this one back. Let us try to now set this to a floating point number. We just talked about narrowing conversion, where the compiler prevents you from losing data in the course of an unassignment operation. Okay, so let's see what will happen here. So if I compile this, wait for it, good, we get what? We get an error. Let's try to read the error message. It says narrowing conversion of 2.066 from double to int. Is that okay? And you see, it didn't give us a warning, it gave us an error. So until we fix this, it is not going to allow the code to compile. This is what I mean by performing narrowing conversion checks. Okay, now let's see whether it is the same for the other methods of variable initialization. So I'm going to set this to a floating point number. Is that okay? Compile this, and bingo, look at this, no error messages, no warning, it just passes through like that. Okay, and the same thing applies to the assignment operation. If I should compile again, 0 warnings, 0 errors. Okay, so to them this is perfectly fine. Is that okay? But by using the brace initialization, C++ or the compiler is going to prevent you from doing such a thing. Another thing you can also do is to define and initialize more than one variable of a given type in a single statement. Is that okay? So if you look at the sample we have here, so we have int my age. So I'm demonstrating what I just said, okay, in the 3 different notations: the assignment, functional, and the brace. Is that okay? All you have to do is to comma separate them, and finally you bring just 1 semicolon. So this is totally allowed so far as they are all of the same data type. So if there's a character data type, for instance, then it means that everything you are going to put here would have to be a character. If it is a float, then everything has to be a float. So far as the data types of many variables are the same, you can put all of them in a single statement and declare or define and initialize them. Now, although this is legal, it actually impedes readability. Okay, writing each variable declaration on a separate line kind of beautifies your code and makes it possible to add comments at the ends of the line. So yes, you can do this, but please, if not for any serious reason, don't do this. An integer can take on either a negative or a positive whole number. Let's look at what we mean by signed integers. Signed integers refers to both positive and negative values. Okay, now the number of bytes they occupy can be obtained using the size of operator. There is this operator in C++ called size of, so we can use it to obtain for every data type the amount of bytes that your compiler assigns it. One thing I want you to know and understand is that the number of bytes occupied by each data type depends on the compiler used, with the exception of the signed character, which is always 1 byte. Okay, now the signed modifier is mostly optional. You can omit it. For all integer types other than the char, you are free to choose whether you add the signed modifier or not. Okay, by default the data types are signed with the exception of the character type. So whether the character type is signed or unsigned depends on the implementations or of the compiler. Okay, it depends on the compiler use. So let's look at a typical example in code. So what I'm about to demonstrate is a piece of code that I've written to spit out the various data types. Okay, so for every data type, it is going to tell us the size in bytes, then the range of values that they can take. Is that okay? The range of values that they can take. So I've done for all the integer data types. So we have char here, we have short int, we have int, we have long int, we have long int, okay, and that is the end of the list. So now let's go ahead and run this code. Okay, so the first one on the list is the car data type. It says that it takes 1 byte, and please take note, I am not the one putting in these values, okay. I'm using the size of operator here, okay, to get it from the compiler. So the byte allocations are exactly what the compiler have assigned to the various data types. I am not the one creating it. However, the range, I'm using a formula which is 2 raised to the power n, okay, 2 raised to the power n. So for instance, if the size of the data type is 1 byte, then it is going to be 2 raised to the power 1, but every byte is made up of 8 bits, so it will be 2 raised to the power 1 times 8. If the size of your data type is 2 bytes, then it's going to be 2 raised to the power 2 times 8 in that order. So that is how I compute the range. Then once you compute the range, you divide it by 2, okay, and you divide it by 2 to get the midpoint, which is 0. Then to the left would be the range, the minimum limit for the negative numbers, and to the right would be the upper limit for the positive numbers. So the character type can pick on 0 up to 256. So there are a total of 0 up to 255. So there is a total of 256 characters that can be represented by an 8-bit character. The next one is the short int data type. Now, so for my computer, the short int, the compiler I'm using assigns 2 bytes to the short int. So this means that short int, if I declare a variable, an integer variable, as a short or of the type short, then it can pick on as a minimum of minus 32,768 to a maximum of 32,767. Now, I will demonstrate another code that will show you what would happen if you try to pick values smaller than this or greater than this. The next one is the int data type. So my compiler assigns 4 bytes to integers. So that means that any value that I create as an integer can assume as low as this value in the negative direction, or as large as this value. Again, the next one is the int data type, a long int, which we can just call int. So you can see that for my compiler, there is no difference between the integer data type and the int and the long int. They all have 4 bytes. Is that okay? So that means by using int or long int on my PC, it doesn't actually make any difference because they all have the same word byte. The next one is called long int, or you can call it long for short. So you can see that my compiler assigns 8 bytes to the long int. Is that okay? So it can pick on as huge as this value. So it can pick on this value. I think there is a mix-up here. You can see that there is a warning down here. Okay, so there is a mix-up. There is a mix-up over there. Okay, so this demonstrates the limits for each of the data types, and trust me, you don't want to go beyond the limit of the data type. Now, to demonstrate that, let me show you a sample code. This is a simple code that I've designed to mimic a banking transaction or a banking application. Is that okay? So you can make a deposit, you can make a withdrawal, then you can reset your account. Okay, something like that. Now, you don't have to understand the codes here. You are still learning, but for demonstration purpose, I had to do this. Is that okay? So just listen to the explanations that I'm going to give you. Welcome to Tech Foundation International Bank. Is that okay? So if you want to make deposit, you just press D. If you want to make withdrawal, you press W. If you want to reset the system, the software, you press R. If you want to quit, you press Q. Is that okay? So now my account balance is 0. I don't have any money in my account. Is that okay? Now, one thing I want you to pay attention to is that the account balance, I use the short data type. The deposit, I use the short data type. The withdrawal, I use the short data type. Is that okay? So what I'm trying to demonstrate here is to show you what happens when you go beyond the limits of the data type. And what I'm going to demonstrate with the short data types apply to all other data types, or at least all other integral data types. So let's make a deposit. Select D, and the amount we want to deposit for now have a lot of cash. So let me deposit some 30,000 Ghana cedis. Okay. All right. So now you can see that my account balance has been updated, 30,000. Then let's say the following day I went in to make another deposit of let's say 5,000. No, let's say just 1,000. Yeah, so you see that everything is working smoothly. Okay, everything is working smoothly. Let's make another deposit of 1,000. Yes, yeah. So the banking software is working fine. Okay, so let's make a deposit of another 5,000 Ghana cedis. So that is even too much. Let's make a deposit of another 1,000. And boom, look at what happens. My account becomes negative. All I have been doing is depositing money. So how come my account says I owe the bank? Is that okay? How come now? This is a typical example of variable data types going beyond data types. Okay, now what happened? You see, previously, before we added the last 1,000, let me reset it. Okay, now we know that the short has a maximum. The maximum value it can take is 32,767. Is that okay? So let's say I make a deposit of 32,767. Everything works fine. Now let's just go in and add one more than what the short can take. So I'll make another deposit of 1 CD. See what has happened. So when you exceed the limit, automatically it will swap, or it will flip to assume the lowest. Is that okay? And you can see that this is actually the lowest, the minimum limit that a short integer can take. Is that okay? So if you are a programmer, be very careful. Be very, very careful about these things. Now let's demonstrate it in the other way around, where we make withdrawals. Okay, where we make withdrawals. Now, so I go to the bank and I'm like, hey guys, I'm broke, so I need some help. Okay, I need some help. So the bank says, okay, we have made your account a debit account, whatever the business guys calls it. So it means that now I can borrow money from it. Is that okay? Now look at something. So I go into my account. I'm ready to make a withdrawal. So I'm going to withdraw money from my bank account. So first of all, let's withdraw 30,000. Okay. All right. So the account says that I owe the bank 30,000. Okay. Then fortunately, yeah, they've given me, I can withdraw, I can owe them up to maybe 10,000 cedis. So the next month I go in to make a withdrawal, and this time too I withdraw 30,000. Now look at this. Now the bank, the system is telling me, instead of owing the bank 60,000, the system is telling me that I rather have 5,536 in my account. What a wow. Is that okay? And because this thing cannot be arrested by the compiler, if you make such a mistake in a real world application, you are going to cause a lot of harm. Okay, that is why I keep saying that when it comes to learning programming, please don't rush it. Don't rush it. Take your time. The language is a tool. You are as good as the knowledge or how best you can use your tools. Is that okay? And some of these things are what we call bug. It can take you weeks, days, stressful hours to figure them out. So please pay attention to them. Anytime you are using any data type, make sure you are not expecting values greater than their limit, or greater than their limit, or lesser than their limit. Is that okay? Good. Now here I'm using cin, the character input, to read data. How would cin also respond if I should type a value greater than the short can take? So for instance, if I want to make a deposit, okay, and I enter something like 35,000, which is way above what the short can take. If I hit enter, you see what has happened? See what has happened here? Now my program has actually jumped. Okay, it has entered into an erratic mode. It's no more responsive. Is that okay? So these things that I have wasted so much time talking about them, they are very dangerous if you misuse them. So please make sure you are appreciating every bit of this tutorial. Now, there are circumstances where we don't need to store negative numbers. For instance, the age of a person cannot be a negative number. You can instruct the compiler not to allow a variable to store negative numbers by using the unsigned modifier. Okay. So for example, by using unsigned modifier on int age, it means that we can no longer assign a negative number to the age variable. Now, one thing you should note is that each unsigned type is different from the signed type, okay, but they all occupy the same memory. The type char, however, is different from both signed char and unsigned char. Okay, the type char is different. The moment you modify the type char with a sign, you get a different thing from, and the moment you modify it with an unsigned, you get another different thing. Okay, so the char type is intended for variables that store character codes, okay, and can be signed or unsigned depending on your compiler. So it's your compiler that determines whether your character, the definition of your character type, is signed or unsigned. Now, that is to say that whether the character type is by default signed or unsigned, it depends on your compiler's implementation. I will make a separate video to talk about character data types in details. Now, when you make a variable unsigned, what happens is that you shift its minimum limit to 0 and the upper limit to twice that of the signed. Okay, so adding signed and unsigned also has the advantage of self-documenting your source code, as it makes it easier to know what values a given variable will or should contain. Okay, so it's a way of self-documenting the codes that you write. By default, using the signed and unsigned modifiers alone, okay, is the shorthand for signed int and unsigned int. So if you see in any piece of program signed, okay, maybe signed age, unsigned age, then by default it's just a shorthand for signed int age or unsigned int age respectively. Is that okay? Now let's look at sample code to demonstrate unsigned, how to use the unsigned integers. Okay, so this is the code. This is the code like the one I ran previously. Okay, that shows the maximum and minimum of the unsigned data types. So let's run this and look at it. Okay, so the first one is the unsigned short. Okay, so you see that unsigned short, the range, it ranges from 0 to 65,535. okay, then unsigned int will range from 0 up to that value. Unsigned long to will range from 0 up to that value. Remember, on my compiler, my compiler actually assigns 4 bytes to both ints and long. Okay, so there is no difference. Then the long actually takes from 0 up to this huge value over here. Okay, so that is what happens when you modify a variable's declaration or definition with unsigned. You shift it from accepting negative values to the positive values. So now the question is, what would happen if I should force a negative number into a variable that I have set as unsigned? So I'm going to use this simple code to demonstrate. I've created an unsigned short integer called age. Okay, so I will ask the user to enter the age. So the user will type something, I'll keep it here, then I'll print the age value out. Is that okay? All right, so let's quickly do that. Okay, so age, let me type 27, and you see that it prints back age is 27. Everything is working fine. Now let's run it this point, but now we are going to supply negative 27. See what is happening here? Maybe you don't get it, but let me run again, and I'm only going to supply -1. You see, where do you remember seeing this number? This is the maximum that an unsigned variable can take. Is that okay? So if you make any mistake and get a negative variable into a negative value into a variable you have declared as unsigned, then these are some of the things that is going to happen. So please don't joke when it comes to dealing with data types. Be very sure before you select them. Each data type has a default value that represents 0. For integers, this is the number 0 itself, okay? But for characters, it is a character known as the null character, okay? And the way we represent it is by using a single quote and a 0. Single quote and a 0 represent null character, okay? Now, earlier I said that it is always a good practice to initialize your variables to a specific value you know, so that you can so that you don't accidentally use the arbitrary number it may contain for any operation. Is that okay? Now, frankly speaking, there are times you create variables and you don't have data for them. Is that okay? Now, the best thing to do is to set them to the 0 of their data type, and using the braced initializer methods actually help do this nicely. So let's look at a code example. Okay, so in this code I've created 4 different variables of different types. Okay, and you see, to do the 0 initialization simply means that put an empty parenthesis, an empty braces there without any value, and by default or automatically the compiler is going to set these values to the default the zeros of those numbers. Is that okay? So now if I print this out, we shouldn't see any arbitrary data or any arbitrary values. They should all be the zeros. Okay, so you can see my age has been set to 0. Gender, you can't see any value there because the null character is actually not a printable character. Account balance is a float and it has been set to 0. It's a leap year, it's a boolean and it has been set to a false. Remember, for boolean data types, 0 represents false. Any other integer, whether positive or negative, represents a true. Sometimes in code, you would like to define variables that have fixed values and cannot change. Okay, these are called constant values. Now, to do this, all you have to do is to modify the variable definition with the const keyword. Okay, and this will tell the compiler that the value of this variable cannot be allowed to change or cannot change. Is that okay? So let's quickly look at a code example of this. Okay, so in this program I have created a variable, a variable with a constant value. Okay, days of number of n days in a week, which stands for the number of days in a week. You see, there are a fixed number of days in a week, which is 7. So if you are writing a program, you would like to safeguard this value so that it doesn't change. Is that okay? And the way you do that is just by introducing the const keyword. Once we do this, anytime we try to modify this value, the compiler is going to detect an error. The compiler is going to detect an error. And fortunately, you can't even do it using a dynamic way of assigning value, like reading input from the user and putting it there. Okay, so let me run this code to show you the output. First of all, we get what? An error which says that assignment of read-only variable. Okay, so by setting const, we make this variable read-only, and you cannot, or you will not be allowed to change the value of a read-only variable. Now another way, let's see whether we can set it from by taking input from the user. Okay, so we are tricking the compiler. We take input from the user and we set it. Let's see whether the compiler would allow that. And again, we have an error which says that invalid conversion from short int to this is a long one. This is a long one. There's a long one. Let me see. Okay, it says that no match for operator. Okay, so we are talking about this operator. Okay, and const short int. Okay, so what this means is that you cannot use the cin object to read values into a variable that has been marked with the const keyword. The moment you mark a variable or modify a variable with the const keyword, you have made it read only. Another thing I want us to look at is what we call integer literals. Constant values of any kind that are directly typed in source codes are called literals. Okay, now every literal has a data type. Every literal has a data type. Now let's start with decimal literals. Decimal literals refers to values in base 10 numeral system. Okay, we know this one. Okay, but then the reason we call them literals is that they have been hard coded into the source code. So the question is, how do we tell the compiler to treat a particular literal, a particular number that has been hard coded into the source code as an int, as a long int, or as an unsigned int? Fortunately, C++ provides a way to do that by appending some letters to the end of the literal. So for instance, -42 followed by capital L or -42 followed by small l represents a literal of the long data type. So the L stands for long. Okay, so it represents literal in the long data type. But one thing that you have to be careful is that if you look at this, you see, if the font, depending on the font, this small l may look like a 1. Is that okay? So I will advise you to stick with using the capital letters. This is clearly an L. Is that okay? It's clearly an L. To represent long int, you use double L. Okay, so L followed by another L to represent long int. Now you can also use the letter U that is either in the uppercase or the lowercase to represent an unsigned integer. Is that okay? And you can also string them together. You can sequence a U and L or LLs together. So for instance, if we want an unsigned long literal, let's say 365, okay, we can represent it as 365UL. So the U means that it is unsigned and the L means that it is a long data type. Whenever you have an integer hard-coded in your source code without any suffix, it simply means that it is an integer. It is ordinary integer. Is that okay? So it is common to insert spaces or commas in numbers depending on the local convention. Okay, so for instance, when we are writing values, huge values like 1 million, we like to insert commas after groups of three digits. Okay, now some countries insert spaces, other countries or other locales would insert decimal numbers. So there are actually countries that rather represent decimal points by commas and commas by decimal points. Okay, so you have to understand this. Now you can't, however, do this in C++. Okay, you can't write a number in C++ like this 32 space that. No, you can't do that. Neither can you do 32 comma that or 32 point that. For the point, the moment you do a point, it will immediately take it as a floating point number. Okay, so you are not allowed to do that in C++. However, from C++ 14 upwards, you can now use a single quote character to mark or to make literals more readable. Is that okay? So the groupings that we use spaces or commas or full stop, depending on the local convention. If you want to do same in C++, then you can use the single quotes. Okay, so this number, which is 10 million, you can do that grouping. Okay, so take note, if you want to achieve readability, what you do is use the single quote, not the commas. In practice, however, when you are using the brace initializer, for instance, to initialize variables, there is no need putting those L and U and other stuff there. Okay, what happens is that the compiler won't actually complain about it. Is that okay? It won't complain about it. Although all integer literals are by default signed int, your compiler will happily convert them to the correct types for you, as long as the target type can represent the given values without loss of information. Okay, so the compiler actually won't allow you to store something like 40,000 to a short, because a short can't accommodate 40,000. But assuming I create a variable short and assigning, I want to initialize it with a value like 500, the compiler would do the conversion for me to convert the 500 from int to the short type for me, okay, without anything. But the moment that conversion would cause or lead to loss of information or narrowing convention, then the compiler would throw an error to that effect. Although it is mostly optional when you are doing initialization to specify those L's and the U's, there are situations where you do need to add the correct literal suffixes. Such situations include when you initialize a variable with the type auto. Now, I will make a video to talk about the type auto in a future tutorial. Another is when you are calling what we call an overloaded function, okay, with an argument. Again, when I treat functions, I will explain what is meant by an overloaded function. Okay, so this is not something that I want you to be worrying about at this moment. Decimal system or the base 10 system is not the only way we can represent numbers in a C++ program. There are other ones like the hexadecimal, which is the base 16 numerical system. We call them hexadecimal literals. So hexadecimal literals are literals in the base 16 numeral system. So to represent a hexadecimal literal, for instance, in your source code, all you have to do is to prefix the value, or in this case, the hexadecimal literal with 0 and x. Is that okay? 0 and x. So your 0 followed by an x. The s, it can be the small case or the uppercase. Is that okay? So for instance, if I want to represent this 999, which is in the hexadecimal value in code, then all I have to do is to suffix it with 0x. Is that okay? And the computer will treat it as a hexadecimal number. So please take note that the moment you put the 0x in front of this, it ceases to be a decimal value. So decimal 999 is not the same as hexadecimal 0x999. We also have the octal literal system. Okay, you can also write integer literals in octal values, that is by using base 8. Now, you identify a number as octal by writing them with a leading 0. Okay, so this means that you should never write a decimal integer value with a leading 0. Okay, if you do so, the compiler will interpret it as an octal value. If you do so, the compiler will interpret it as what? As an octal value. So the moment I do something like 065, it will be equivalent to 53 in decimal notation. Is that okay? And take note, the moment you put 0 here and you put something like an 8, you will get an error in your source code, but the compiler can actually check immediately that the number 8 does not belong to the octal system. The octal system is made up of numbers from only 0 up to 7. Then we also have the binary literal. These literals were not in C++ until version C++ 14 standard. So if you are somebody who have been coding in C++ for quite a long time using the old standard, this will be quite new to you. Okay, so you write integer literals as a sequence of binary digits, and here we are talking about zeros and ones. Okay, prefixed by 0b. Now the b can be the lower b or the upper b. It's up to you to decide which of them that you use. And as always, all the literal systems on the number systems that I've talked about, you can still append the L's, the LLs, and the U's to them. Is that okay? And they'll just behave normally like we have in the compiler system. We have in the decimal system. Now, as far as the compiler is concerned, it doesn't matter what number base you choose when you write an integer value. Ultimately, they will all be stored as binary numbers. Now, the different ways for writing an integer are there for you, so that depending on which of them is convenient, okay, you can choose it. Now, you choose one or other for the possible representations that suit your context. So maybe you are writing a program to process some RGB stuff, okay, then it will be much convenient to use the hexadecimal system to represent your integer literals in code. Is that okay? But also note that you can use a single quotes, okay, like the way we separated the group of zeros with a single quotes. Okay, we can also separate group of maybe by bits or group of hexadecimal values with the same semicolon, just to improve readability. Now quickly, let me show you some of the effects of having this hexadecimal, octal, and binary literals in code. Okay, so in this code I have put together a couple of statements that will convert. So look at this. For instance, here we have a code that is going to print out some hexadecimal values. Now take note, if you can put them as literals, but if you are printing them to your cout, for instance, they will be converted to base 10. Is that okay? They'll be converted to base 10. So for instance, ff here, okay, can be written as 0xff, because ff, so it's a hexadecimal value, so 0xff. Is that okay? So if I run this code, it's going to give me its equivalent in base 10. It will not print it in base 16. And then I can also initialize variables with it. So you can see here I have the value 0xDEAD, which is actually a hexadecimal value. Is that okay? So I can conveniently initialize a value with hexadecimal values. I can also do that with octal, and I can also do that with binary. The idea is that use what is convenient for you. Use what is convenient for you. So let's go ahead and run this code and look at the output. Okay, so ff represent 255 in base 10. The value for red, okay, so the variable that we created that had the 0xDEAD, this is the decimal equivalent of the DEAD hexadecimal value. Now 77 in base 8. Oh, sorry, I think I'm okay. 77 is 63 in base 10. So 77 base 8 is 63 in base 10. Is that okay? And 1011 base 2 is 11 in base 10. Is that okay? So just feel free, which of them work best for you, just use it. Now to give a warning, or so to caution you, sorry, for instance, assuming I want to create a variable called telephone number and to store a telephone number. Usually telephone numbers begin with 0, so I'll be tempted to write this, right? Now let's see what happens if I print out the telephone number. So is this the telephone number we entered? No. Okay, so who can tell me what is happening? Good. So what is happening is that because it saw this leading 0, it took this whole number as an octal literal. Okay, so the answer that it gave, okay, the value that it gave is actually the base 10 representation of this octal literal. And again, please pay attention to this basic stuff when it comes to programming. They are the same things that will be giving you bugs and horrible nights some time to come. Alright, this is the end of the tutorial. I trust you have learned something important. Please take this from me. Do not rush the learning of programming. Try to spend time to understand the requirements of the language you are using, else you would rather waste more time debugging your program in future. Now, I want to express my gratitude to our partners and sponsors. Saytech, they design and build smart agricultural machinery suited for Africans' conditions and use. They also provide fabrication training services and computer-aided design services to manufacturing industries. Siratech Technologies is an electronics component retail shop at China House, Adum, Kumasi. Contact them for all your electronic components, including Arduino kits and sensors of all kinds. Teskin Enterprise, the #1 distributor of electronics components and electrical hardware. You can locate them at Achemfo Market in Kumasi. You can call him for all your electronics components from analog to digital devices. Now, electronics deals with a smart electronic system development, software and web applications, IoT systems design, project and research, and IT training. Contact us for assistance in your next billion-dollar project. If you want to be a sponsor or partner with us, please call us on the number displayed on the screen and we'll be happy to have a chat with you. You also, my dear viewer, you have the power to contribute to support this program. You can donate in cash or in kind. We actually need quality cameras and sound systems for our video recordings. Your support will be very much appreciated. You can Momo us any amount using the Momo account on the screen. And remember, Kitwabiensa, you can donate 5 cedis, 500 million Ghana cedis to help make Africa tech literate. Alright guys, thank you for watching. Don't forget to subscribe and like this video. We want to know how we can make this training better for you. So let us hear from you by posting a comment in the comment box. Okay, I am Professor and this is Tech Foundation Africa.